Okay, this is going to be a real quick video on average value of a function. And so before we talk about average value of a function, why don't you think back to how you take the average of a set of numbers? So think about that for a moment. What would you do if you were taking the average of a set of numbers? Well, if you're anything like me, you'd think you'd start by adding them all up, and then you'd divide by the number of numbers you have. And the way that we're going to find the average value of a function is going to be exactly the same. So we're going to start by adding up all the values of the function. And we know that a way that we can add up all the values of a function in some sense is by taking the integral of the function. So we're going to start by integrating the function from a to b. Then we're going to divide by the number of numbers. Now, of course, there's an infinite number of numbers between a and b, provided that a and b are not equal. So what we're going to do is we're going to divide by the width of the interval. So divide by b minus a. And so in the textbook, you might see this written as 1 over b minus a times the integral from a to b of f of x with respect to x. But it's really the same thing. And I kind of like this form because it calls back to how we actually find an average. We add them all up and then we divide. Okay. And in a minute, I'll kind of draw a picture for you about what the average value of a function really represents in terms of its graph. Okay, so we'll start with a pretty straightforward example. Find the average value of this function on the interval 1 to 4. Okay, well, I know that the average value of f, which I might call f bar, is going to be equal to the integral from 1 to 4 of f of x dx over 4 minus 1. And that's going to be 1/3 of the integral from 1 to 4 of 3x squared minus 2x dx. And now that we know how to actually take these integrals, I'm going to find an antiderivative. An antiderivative for 3x squared is going to be 1x to the third. An antiderivative for negative 2x is going to be negative x squared. And I'm going to plug in 1 and 4. And I'm going to evaluate this. So I'm going to have 1/3 of 4 to the third is 64 minus 16 minus, okay, well 1 to the third is 1 minus 1 squared is also 1. Okay, and it's going to be 1/3 of 64 minus 16. And this would be a safe place to stop if we were working on the free response section of a test or something. But if you really wanted to know what the average value of this thing was, you need to do some arithmetic. So 64 minus 10 is 54, and 54 minus 6 is going to be 48, and you divide 48 by 3, and you get 16. All right, here we've got some multiple choice questions from AP exams that are asking you about the average value. And on the right, they're kind of asking about the relationship between average value, average rate of change, and average value of the derivative, which is a relationship I really like. Okay. But I'll start with 97 AB number 20. And so I think that this is one that you should do on your own. So if you're watching this video, you should pause the video. You should get one of the answers, and then check your work against mine. And then in about 10 seconds, it's going to pop up with the answer. All right, here you go. So you probably got down to about this point, and you thought to yourself, well, what's the problem here? I don't see that answer choice. And, over time there have been fewer trig identities required of y'all on the AP exam. And 97, that wasn't that long ago. But this one, you do need to know that sine of -3 is the opposite of sine of 3. So this is actually equal to 1/8 of the sine of 5 plus the sine of +3. And that is going to be answer choice E. Okay, and then over here, f is going to be a twice differentiable function with f of 1 equals 2 and f of 3 is 7. Which of the following must be true on the interval 1 to 3? Okay, well, right off the bat, average value of f equals 9/2. That would require us to know the integral of f between 1 and 3, and they didn't tell us anything about that, so I'm just going to eliminate that choice. That's just not going to be the case. And see, it's only answer choice E, so, that one just wasn't going to be, it wasn't going to be a winner. So the average rate of change of f, and I know it's been a long time, but the average rate of change is rise over run, so that's 7 minus 2 over 3 minus 1, which is 5/2. Okay, so 1 is definitely an answer. Okay, so 1 and 3 only are gone. So now it just is left to us to determine the truth of number 3. The average value of f prime equals 5/2. Okay, well, let's just kind of set up the average value of f prime on the interval 1 to 3. So it's going to be 1 over 3 minus 1 times the integral from 1 to 3 of f prime of x dx. Now, wait a second. I know an antiderivative for f prime, and that's going to be f. So that's going to be half of f of x evaluated from 1 to 3, which is half of f of 3 minus f of 1. Which is that 5/2, okay? So that's true. So it's 1 and 3. And the point I want to make with this is that the average value of the derivative is the same as the average rate of change. Because if you take average rate of change, that's f of b minus f of a over b minus a. And average value of the derivative is equal to 1 over b minus a times the the integral from a to b of f prime of x dx, which I showed just above here is f of b minus f of a. So I'm going to actually change that. 1 over b minus a times f of b minus f of a. And we see that these are the same thing. Okay, so the average rate of change of a function is the same as the average value of its derivative. Here we've got a particle motion problem. Velocity given by 6t squared minus 3t. Find the average velocity between t equals 0 and t equals 4. Well, this really means the average value of v. Okay, so average value of v, which is going to be the integral from 0 to 4 of v of t divided by 4 minus 0. Okay. Well, that's going to be 1/4 of the integral from 0 to 4 of 6t squared minus 3t with respect to t. And that's going to be 1/4 of 2t to the third minus 3/2 of t squared from 0 to 4. 1/4 of, okay, 4 to the third is 64, 128. 4 to the 2 is 16. 1 1/2 16s would be 24. And then when I plug in 0, I'm going to get 2 zeros. So that's going to be 1/4 of 104. And that seems like it would be 26. All right, next we've got the rate at which water is entering a tank is given by r of t, which is the 4th root of t squared plus 1. R is measured in gallons per minute, and t is measured in minutes. What's the average rate of water flow? Okay, so I'm looking for the average value of r of t, which is going to be, okay, between minute 2 and minute 5, r of t dt. Okay. And, well, I don't know an antiderivative for the 4th root of t squared plus 1. In fact, I suspect that no closed form antiderivative exists for that function. So when that happens, we are left to use technology. So you would get out that calculator, you would use Math 9, and you would find the answer. But in the interest of time, I'm just going to kind of skip over that. The last thing I've got is approximating an average value using a Riemann sum. Okay, so the average temperature is going to be the average value of W. w bar equals the integral from 0 to 20 of w of t dt, and then I'm going to divide by 20 minus 0, so that's 1 over 20 of that. Okay, so what I'm going to do is I'm just going to work on the integral. I'm going to find a trapezoidal Riemann sum. Okay, so it's you average the bases, and then you multiply by the height. And then you average the bases, and multiply by the height. Do that 2 more times, which I just did for you, and then we're going to divide that by 20. Okay, so I'm going to take that, and I'm going to divide by 20, and that's an ugly number, but it is a number, and it is the average temperature. And, you know, I'm not a huge believer in using a calculator for these, because if you were going to use a calculator, you're going to use technology at all, you might as well, you know, actually plot the points, maybe interpolate some kind of curve using a regression technology, and then maybe integrate that. And I'm kind of, you know, I believe in for a penny, in for a pound. So this is a number that approximates the average temperature using a trapezoidal Riemann sum. The last thing I want to show you is kind of the geometric interpretation of the average value. Okay, the integral from a to b of f of x, which is graphed in blue, is the amount of area, right? And so what I'm going to do is I'm going to shade in that area. All right, suppose the average value of this function was, I don't know, it's going to be somewhere between f of a and f of b, based on this drawing. And let's just say it is right here. So I'll call that, just f average. If f was constant at f average throughout this whole thing, then it would have the same area underneath it as f has between a and b. So this shaded area would have the same value as the shaded area I had shaded before. Okay, so that's all I've got to tell you about average value. We got a good worksheet on it. I'll probably attach the worksheet and maybe its key in the description of this video. And, give it a shot yourself.